So, all right, hopefully it goes.
All right, let's get this show
I'd
started.
like you guys to just have an eye on. Where's this?
Hey,
What's it?
let's play.
So basically what we wanted to do was show that on a bigger screen so everyone could actually see it. That was the whole thing, but we couldn't actually connect to the computer that's being used. So yeah, so that's, as you guys may have noted, as you guys may have kind of understood from what we were talking about, we're doing the challenge
Space wearables, yeah. And we've gone with designing an actual suit. So you don't see that, that's not the whole thing here, but that's at least a part of it, what we've got. So, why a suit? So what we'd looked at, we thought, well, our ladies and gentlemen up there in space are in constant danger, aren't they, from many different things, and we want to make their environment as safe as possible. Also, for when they're working, we want them to their equipment and all that to be at hand conveniently. So we've thought about bringing these two things together, convenience and safety, and
so putting those two things together, what the astronaut actually thinks is that it gives him a bit of comfort and eases his mind because of safety, and you don't have to carry too much equipment. Yeah. So let's just talk, before we go into that slide over there, I'd like to talk about the suit a little bit. The suit actually will be made as, currently the arm you can see that's kind of a little bit light bluish, and it's got two gray tracks. Those gray tracks are actually conductive material that can conduct electricity. Yes, I'm going to come over here as well, just show everyone. Yeah, so basically what the whole point was this was it would go down to your glove. You could actually measure electricity, the change in voltages. You can measure, find out if there was a fault in the equipment on the spaceship or the shuttle you're working on, or even outside, you know, something if you're working on something small. So it kind of reduces the need to carry bulky equipment around. Another thing we have is embedded a heart sensor to measure the heart rate. All that is actually hooked up to a central processing unit, which is quite big at the moment. We agree with that because we want it to be really small. We may work on that in the future. So these are just some of the things we've implemented. The camera as well, as you would have seen, the laptop was going around. There's a live feed actually still working there right now. So yeah. I'm moving on, getting conceptual. What we did was we tried to draw up sketches to see what our concept would actually look like in the final stages. This is just like one of the early stages. It's not a final concept yet. It's just some of the early drawings we did. And on the board over there, there's a picture of the board showing lots of brainstorming that went in. We decided we had to select what we actually could implement in the 48 hours to show the judges and show everyone else, and what could possibly be implemented in the future.
Yeah.
So friends, as I said, we were doing international collaboration with people in someone in the UK and Toronto. They were mainly responsible for drawing up concepts because they were really good at designing, drawing and illustrating. So we've kind of got like a brief outline of what the suit would look like on the far end. This over here in the middle is the HUD, the heads-up display, that we'd like every suit to have. So it basically reduces, so we can augment what the person that's wearing the suit is looking at. He'll have instructions coming from HQ saying, hey, you've got to do this. It's all going to come up on the suit. Something like Google Glasses, but on a bigger and better scale. This is what we imagine the heads-up display would actually look like when you put it on. It's got two bars on the side. You can have a video feed. You've got commands coming down on the bottom, whereas similar to what we actually have shown everyone over there. And that is a really close-up view of the gloves. As I was talking about, you've got this measuring probes where you can measure voltage and stuff like that. That's a really close-up view of what we were going to have on the gloves.
Yeah.
All right, so
yeah. Oh, and just adding on to that, there are also further concepts that we would like to see implemented later on, but we didn't get around to that right now, such as we took the idea of puncture-proof tires that release gel when they're punctured, probably implementing a layer of that in the suit, so if a puncture does occur, it gives the person enough time if they're outside an EVA to come back into safety.
another thing we thought about implementing was in the future was carbon nanotubes that can be made into really thin material, can be wound into really thin material.
Yep.
What happens is you pass a voltage through it, it gets hot really quickly, and that creates a temperature differential in the air. Basically, it becomes a speaker. So it kind of looks like material stitched onto your suit, but it's actually a speaker that can, it's got sound coming out, and you can kind of talk through it as well, I'm pretty sure,
Yep.
later on.
2 minutes left.
Yep. So, here are pictures. Well, we actually covered that already. So we got the fabric and the microprocessing computer.
Yeah.
Took care of, yeah.
No.
Okay. And again?
Yeah, so just since we were actually having technical difficulties putting the heads-up display on the main screen, we kind of covered a lot of things we wanted to talk about at the start, at the end, actually. So, yeah, so that's basically it. Yeah.
All right, so collaboration.
As we already talked about mostly as well, because of not being able to display a proper 3D feed.
Yeah. So we had 2 people contact us. We wanted someone to illustrate our designs. We didn't have any designers ourselves. We're all engineers, mostly. One person from the textile department as well, and IT. So we don't have any graphic designers, so we decided to put out a little ad, and we got 2 people coming back, one from York in UK and one from Toronto, Canada. And we got them to pretty much, we gave them our ideas, and we asked them, can you visualize them?
And as we were talking about the heads-up display and everything we showed before, that was kind of like made specifically by them for us to use. So we kind of had a lot of conference calls through Skype discussing what we think is cool, what we think is not cool, how we'd like it to be at the end.
Yeah.
And yes, I think it turned out pretty good. And we actually all had lots of fun working together with people overseas as well.
Yep. So just as you see there, we use a lot of different media. We use Google+, Twitter, GitHub for code validation, WhatsApp. I can't name it all, but yeah. And in the end, we all had fun.
That was actually one of the main reasons why we actually were doing this challenge, because it wasn't to actually compete, it was just to get together, have some fun, see if we can actually get something cool out of it. And I think we actually did make something cool. Yeah. So, do you guys have any questions for us?
Great presentation. And I like the fact that you've got radical in your acronym, TETRIS. That's good. So I understand the telemetry and what you're trying to do to improve on NASA's existing spacesuits, but so these are to be used outside the space vehicle, I assume, and so how do you compensate for all the hard physical things like pressure, like again protection from radiation, etc.?
Currently, the suit we showed in the design phase is to be worn inside, but we haven't got to the phase of designing a suit that could be, we've kind of like, we're thinking about it, but we haven't got there. There's a suit that can actually clip onto the suit that you're wearing right now, which can be used to actually go outside. This suit is mainly to be used inside the space station and reduce the need for, like, you know, having a lot of different clothes lying around everywhere. You got to change to this and that.
Yeah, we're trying to make it modular, so it's pretty much in layers. You can put this layer on, wear it inside or outside, but when you're going outside, you will need that other layer on the outside that we haven't done. Yeah.
As we discussed before, we were doing something about the puncture. You know, if the suit gets cut, there's going to be a gel layer inside the suit. That gel layer was actually going to be in the outside layer. So as you're going outside somewhere, obviously there's probably pressure difference. You've got, if you're in space, there's no oxygen, stuff like that, and that gel would actually protect you for a little bit until you can get inside and get another suit.
Cool.
Right, Candace?
That's right. So a lot of the technology that you're describing is either in production or in R&D at the moment, you know, here on Earth. Is there anything that you can think of that would be absolutely unique that you would need to monitor in space that, for instance, you know, I can't even think of anything off the top of my head, but just wondering if you kind of brainstorm some of those ideas as well.
Imagine, well, the thing is, what we really did was like, we kind of took the technology that's available now and that's still in R&D, and we implemented it, let's say, in 20 years at either time. Imagine space being commercialized, and you've got locales everywhere. So the reason we put a camera there is so that there's less kind of mistakes happening. You can be monitored and stuff like that. But yeah, for example, the Apollo 13, you know how I think everyone's probably seen the movie, right?
Yeah.
Okay.
I think those are one of the most main
Richard?
inspirations.
Well done on pulling it together and the physical presentation. That's obviously easy in concept perhaps and hard in actually pulling it together. Where do you think you pushed the boundaries the most? And what was quite good to get each of you to answer this, what was your favourite part of this project? The part you're most passionate or proud of?
For me, it was actually coming up with the idea and trying to get a lot of people involved, because we kind of formed as a group maybe 3 or 4 days before the actual event. So I think that was the one part I enjoyed the most, was like organizing the group and getting things done, you know, putting ideas out there and kind of managing it up. Guys?
Yeah.
Oh, you want me? Okay. Well, I was going to pretty much say something along the same lines. Just seeing everyone come together from all these different areas that you wouldn't expect to normally, you know, collaborate on an everyday basis, and just come together to make something that no one person can make alone.
Great. Okay, thank you very much. The last team.
Do you want us all to answer as well? That's good.
Yeah.